everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over special products, but specifically our difference of squares. So we're going to be expanding binomials into polynomials when we are using our formula for our difference of squares. When we're given two binomials that will use our difference of squares model or pattern, we are going to expand it without using foiling. We're going to see what that polynomial becomes with our quick method of using a formula. So let's take a look at that formula to see what's going on. So for this formula, I have to look. I'm giving two binomials that are being multiplied with each other. When they're being multiplied together, I have to look. Is my first term and my first term the same? Is my second term and my second term the same? And then I look, does one have a plus? Does one have a minus? Then I'm good to go. If not, if they're not the same terms, and one with a plus and one with a minus in between, then you need to use foiling. But instead, if this works, if it's the first term is the first, the second is the second, a plus and a minus, then you can use this formula to be able to get your answer in a quicker manner. So if I look at an example, my first term here is x, my second term is 3. My first term is x, my second term is 3. I have a plus and a minus. So I can use my formula of a squared minus b squared. So I am going to square the first term, so x squared is x squared. Then I'm going to square my second term, 3 squared is 9, and I throw a minus in between them. So when they have the same, one's a plus, one's a minus, all you do is square the first term minus squaring the second term. Let's take a look at a problem so we can fully understand what we're doing here. So we have this problem here to start, and I have to look. My 2x and my 2x are the same. My 1 and my 1 are the same. One has a plus and one has a minus. It could be flipped. This could be the minus and this could be the plus. As long as one has one and one has the other, we are good to go. So what we're going to do first is use our equation, a squared minus b squared. I am going to square my first term. So I have 2x, and I'm squaring it, minus my 1, which I can put in parentheses, squared. 2x squared, I use my power rule. I raise 2 to the second power. 2 to the second power is 4. I have my x to the second power. Once I raise it, I have to use my power rule, which means I multiply those exponents. So the 1 times the 2 gives me x squared, minus 1 squared, which is 1. So the reason why this problem works is because if I do FOIL it, I get 4x squared minus 2x plus 2x. That minus 2x and plus 2x cancel each other out. So there is no more middle term. So I am just left with the first term squared because I'm multiplying it by itself minus the second term squared because I'm multiplying it by itself. Let's take a look at this other problem here on the board. So I have this problem here. I'm going to look, x and x, they're the same. 3y and 3y, they are the same. One has a plus, one has a minus. Beautiful. So I'm going to use my a squared minus b squared formula. I square the first one. I get x squared. I do my minus. I square the second term. I do 3 to the second power, which is 9. I do y, and I multiply its exponents, which is y squared. Let's take a look at one more problem, a little bit elevated, so we fully understand this concept. So I have this long problem here, and I'm going to look. I have 2x to the 5th, y to the 3rd. I also have this in the next one. I have 6xy to the 3rd. I also have that one in the next one. One has a minus, one has a plus. I'm good to go. I'm not going to FOIL this normally. I'm going to use my special products rules for my difference of squares. So what I'm going to do is I'm going to square this one, which means I do 2 to the second power. It's like I have it just like this. I do 2 to the second power, which is 4. I do x. I multiply my exponents. X to the 10th. I multiply y to the 6th. I always put a minus in between. I'm now going to do the same thing here. I'm taking this and I'm squaring it. So I do 6 to the second power, which is 36. X to the second power, then y, 3 times 2 is 6. So for this rule, all we are using is our power rule. Once we determine that it is the first binomial being multiplied by the second binomial, but the only difference between them is one's a plus and one's a minus, or one's a minus and one's a plus, we are able to use this formula. So I hope this was helpful to figure out how we would solve problems using the difference of squares special products rule.